So this article is from ULAM Labs, right? Today is June 26th, 2025. It's Thursday. The title today to read is DePIN Crypto, How It's Revolutionizing Infrastructure in Web3. This article is by Simon Bielas. 10-minute read, last update, December 30th, 2024. So it's a 6 months old article, but quite recent. DePIN, decentralized physical infrastructure networks, projects are connecting blockchain technology with real-world infrastructure in interesting ways. These networks let people use crypto tokens to build and manage physical systems, everything from Wi-Fi hotspots to solar panels. By decentralizing ownership and governance, DePIN enables more transparent, efficient, and resilient systems, aligning with the core principles of Web3. As industries like telecommunications, energy, and data storage embrace this innovation, DePIN is emerging as a key driver of decentralized infrastructure, bridging the gap between digital and real-world networks. What is DePIN? DePIN stands for Decentralized Physical Infrastructure Networks. It combines blockchain technology with physical assets to decentralize the ownership, governance, and operation of infrastructure systems. Key features: blockchain-based, right? Community-driven and individualized. Blockchain-based ensures security and transparency. Community-driven. Participants share and manage physical resources. Incentivized. Contributors earn rewards via tokenized systems, right? Incentivized. Tokenized, incentivized, tokenized. Understanding DePIN. What is DePIN, right? Decentralized physical infrastructure networks, DePIN, are blockchain-based systems designed to manage and govern physical infrastructure assets in a decentralized manner. Unlike traditional centralized systems where governments and corporations control infrastructure, DePIN enables community-driven ownership and operation. This is achieved through blockchain technology, smart contracts, and tokenization, ensuring transparency, security, and fairness in managing resources. At its core, DePIN merges blockchain networks with real-world infrastructure. Participants contribute resources such as bandwidth, energy, and storage, which are pooled and distributed across the network. In return, contributors are incentivized with tokens representing ownership, governance rights, or access to network services. This model creates a decentralized system where value is shared among participants rather than centralized entities. Often called DePIN Crypto, these blockchain-powered networks are revolutionizing infrastructure by decentralizing ownership and governance. How DePIN works: 1. Contribute resources. Share physical resources like bandwidth, energy, and storage. 2. Blockchain and smart contracts. Blockchain ensures security and transparency. Smart contracts automate processes and rewards. 3. Earn tokens. Participants earn tokens for network contributions. How does DePIN work? DePIN relies on a combination of blockchain technology and decentralized governance mechanisms. Here's how it works. Smart contracts. automated agreements that handle resource distribution, monitor usage, and execute payments securely and transparently. Resource distribution, monitor usage, and execute payments securely and transparently. Tokenization. Physical resources are represented as tokens, allowing them to be traded or used within the network. Physical resources are represented as tokens, allowing them to be traded or used within the network. These tokens also incentivize participants by rewarding contributions such as bandwidth or storage capacity. Distributed network. The infrastructure is owned and operated collectively by participants, creating a decentralized platform that eliminates single points of failure and reduces operational bottlenecks. For example, participants in a decentralized wireless network like a Helium provide network coverage through hotspots, earning tokens as a reward. This fosters a peer-to-peer marketplace where physical resources are shared and monetized without reliance on traditional centralized authorities. Advantages of DePIN: enhanced security and transparency. One of the most significant benefits of decentralized physical infrastructure networks, DePIN, is their ability to improve security and transparency. Traditional centralized systems often suffer from vulnerabilities such as single points of failure, making them prone to cyber attacks and operational outages. DePIN eliminates this risk by distributing control across a network of participants, ensuring that no single entity can compromise the system. Blockchain technology plays a crucial role in providing transparency. Transactions, resource allocations, and governance decisions are recorded on an immutable ledger accessible to all network participants. This level of openness reduces the risk of fraud, corruption, and mismanagement, fostering trust within the ecosystem. Scalability and resilience. DePIN offers a decentralized approach to scalability, allowing networks to grow organically as new participants join. In traditional centralized systems, expanding infrastructure often requires significant upfront investment and approval from central authorities, creating bottlenecks. DePIN, on the other hand, allows contributors to add resources such as bandwidth, storage, or energy without centralized intervention, enabling rapid scaling. Additionally, decentralized networks are inherently more resilient since resources and decision-making are distributed. These systems can continue to function even if some nodes fail. This resilience is particularly vulnerable for centralized infrastructure like energy grids or telecommunications, where downtime can have significant consequences. Lower costs and efficient resource allocation. So they use a distributed file storage like a FILECOIN system, so that there's no single point of failure, and if there's any failure in the node, it doesn't affect their management or monitoring, or all the systems still running okay or up, right? Lower costs and efficient resource allocation. DePIN reduces the operational costs associated with maintaining physical infrastructure. By incentivizing individual participants to share unused resources, DePIN minimizes the need for centralized entities to invest heavily in infrastructure development. This efficiency also extends to resource allocation, as smart contracts dynamically adjust to demand and supply, optimizing the use of network resources without human intervention. For example, in centralized energy networks, tokenized resources allow for real-time market-driven pricing, ensuring that energy is distributed where it is needed most. This eliminates inefficiency often seen in centralized systems such as overproduction or underutilization of resources. DePIN versus traditional systems. Future DePIN, ownership community-driven, centralized control. Transparency, blockchain ensures full visibility, limited and opaque, scalability, flexible, and organic growth, slow and costly, resilient distributed, no single point of failure, prone to outages and failures, incentives token rewards for participants, high operational costs. Key components of DePIN, blockchain technology. A blockchain is the backbone of a decentralized physical infrastructure networks, DePIN, providing the secure, transparent, and immutable ledger necessary for centralized operations. By recording transactions, resource allocations, and governance activities on the blockchain, DePIN ensures that every action within the network is verifiable and resistant to tampering. This transparency is critical for building trust among participants and enabling the seamless integration of physical resources into digital ecosystems. Different blockchain platforms such as Ethereum, Polkadot, and Solana are often used to power DePIN projects. These platforms offer the flexibility and scalability needed for various use cases, from decentralized storage to energy distribution. Smart contracts. Smart contracts are automated programs that execute predefined conditions without requiring intermediaries. In DePIN, smart contracts play a pivotal role in managing resource allocation, monitoring network activity, and enforcing rules transparently. For instance, a smart contract in a decentralized energy grid might automatically adjust the token rewards based on real-time energy contributions, ensuring fair compensation for participants. By removing the need for manual oversight, smart contracts streamline operations, reduce transaction fees, and minimize the risk of human error. They also enable the creation of decentralized marketplaces where participants can trade physical resources such as bandwidth, storage, or computing power. Tokenization. Tokenization is a cornerstone of DePIN, converting physical resources or assets into digital tokens that can be traded, transferred, or used within the network. These tokens often represent ownership rights, access privileges, or governance power, incentivizing participants to contribute resources to the network. For example, in FILECOIN, tokens represent storage capacity, rewarding participants who share unused space. In Helium, tokens incentivize users to provide wireless network coverage through hotspots. These tokenized economy enables DePIN to operate as a self-sustaining ecosystem. As the network grows, the value of its tokens often increases, creating additional incentives for participation and innovation. The tokenized model of DePIN crypto allows contributors to earn rewards while creating scalable and decentralized systems. The best DePIN crypto project, Helium Network. The Helium Network is one of the most well-known examples of DePIN in action. It operates as a decentralized wireless network that provides connectivity for Internet of Things devices. Participants deploy Helium hotspots, which act as nodes to offer network coverage. In return, they earn HNT tokens as rewards. By decentralizing wireless network infrastructure, Helium reduces the need for large-scale telecom investments. The network has already grown significantly with over 88,000 hotspots deployed globally, offering a scalable and cost-effective alternative to traditional centralized systems. FILECOIN is a decentralized storage network that allows users to rent out their unused storage space. Participants are incentivized with FIL tokens, which represent the storage capacity they contribute to their network, FIL tokens. Unlike traditional cloud storage providers such as AWS or Google Cloud, GCP, right? Google Cloud Platform, FILECOIN operates as a peer-to-peer marketplace, offering cost-effective and resilient storage solutions. As of Q3 2024, the FILECOIN network has a total storage capacity of approximately 23 exabytes EIB, with around 2.2 exabytes of data actively stored. This demonstrates a growing adoption rate, with about 30% of their capacity utilized for active storage deals. FILECOIN provides a transparent and secure alternative to centralized systems, ensuring data integrity while reducing dependency on centralized providers. Render Network. The Render Network offers a decentralized platform for accessing GPU computing power, particularly for rendering 3D graphics. Artists and developers can use Render's distributed GPU network for tasks like creating digital content or rendering virtual reality environments. Participants who contribute GPU power are rewarded with RNDR tokens. By decentralizing access to higher performance computing resources, Render Network reduces costs and barriers for industries like animation, gaming, and virtual reality. It also fosters innovation by enabling broader access to tools traditionally limited to centralized providers. THETA Network. THETA Network focuses on decentralized video delivery, enabling users to share bandwidth and computing resources to improve streaming performance. Participants earn THETA tokens by contributing to the network, which powers a more efficient and cost-effective content delivery system compared to traditional content delivery network CDNs. Katie, my company, has CDN services. THETA Network's peer-to-peer model ensures that video streaming is not only decentralized but also optimized for lower costs and faster speeds. This makes it a valuable solution in the era of high-demand video content. Challenges and consideration, regulatory hurdles, right? Technical complexities, adoption barriers. future, yeah, I will get back to this part later, right? I have to go now. Thanks for listening. Have a wonderful Thursday.